morning, everyone. So you're here to listen to my talk. It's about Bun. I'm DEVLIN DULDULAO, and I came from Philippines, now working in Oslo, Norway for 4.5 years. Yeah, a little bit about me. During the pandemic, I couldn't go back to Manila and see my family, so got nothing to do. I also couldn't go anywhere in Norway, so I decided to write some books, one book, and then followed by another, and followed by another. Okay, lots of work, and I wouldn't recommend if you're gonna try writing a book alone, because it's a lot of work. So yeah, so much for that. So what's the agenda? What is Bun, right? This is just a quick rundown. Features of Bun, like package manager, test runner, bundler, runtime, benchmark, and here I have a little warning or like information. Take it with a grain of salt. If I were just try it on your own, right? Because sometimes this bias in benchmarking, but it's good if you're gonna see it for yourself. Isn't it right? Demo. The demo's gonna be like every maybe it would be every 5 slides. Okay, it's not just one demo and then done it. So I'm gonna keep back and forth slides and demo and key takeaways. But why are we here? What's up with this bundler? Is it just about the performance? Yeah, performance saves time, right? And time is money. This performance can improve the DX or the development experience of a developer, which is it let us, it satisfies us and enjoyment of building something. But there's also something in performance that we're not, directly connected. It's about slowing down the global warming. Well, how is that possible? So imagine if you have a tooling that runs 100 times faster than the original one that you're using. For example, CI/CD, right? On the CI, it's going to run or build your application like quicker than previously, and then the server will go into idle mode, which saves energy, right? Saves the energy of server, saves. So this is not only about performance and then here you go, developer experience. No, this is saving electricity that cloud services are using, and in effect it slows down the global warming, because that's why we have this Earth Day, right? Once in a year, right? What's the Earth Day? It's turning off everything so we can at least, right, save or again slow down the global warming. But anyways, we can now move to who built Bun, right? Jared Summer. So this guy who was responsible for this bundler and other things in this bundler. And it's not only him. There's also Dave Caruso, Ashkan Partove, and 580 more contributors in this Bun. And so why did the creator of Bun, choose to build it on top of Zig? Jared said mainly because of its readability and easy to understand nature of the programming language, which helps him to write performant code. Just to give you an example how the Zig would look like, because normally someone would write a bundler using Rust, right? Because Rust is fast. And here's Zig. Let's say you want to create a function that calculates the square of a number, but instead of doing it while your program runs, you want it to figure it out before your program even starts. So at compile time, right? So with comp time, so this is a feature in Zig, you can tell Zig to calculate the square of a number when the program is compiled. not when it's running. So this means your program already knows the result of that function, before it even starts. So comp time is like having a smart helper in Zig that lets you do things before your program runs, making your code faster and more efficient. So by building Bun, on top of Zig, the creators have made or were able to prioritize performance, stability, and compatibility, and that's exactly what we get with Bun, a modern JavaScript runtime that built for speed. Okay, wanna do a quick demo here of Zig, just to give you a closer look of what's Zig. So I have here the command. Zig would look like this, right? No, it's all good. So have your function here, your main. We're going to build this. Right, so we have the binary here, and now what we can do is try to run this. Zig. Oh. Nope. That's one more time. Okay, got it. So square of 5 is 25, but as you can see here, it didn't, it's not going to it's going to just show you the result of the square rather than showing you what this function is written here. And you will see this also later when I do another a demo about macro, which is similar here. We're going to build it, but we're just going to extract the result of this function, this return, another demo, and not showing you the function, this square in the source code. You know what I mean? Because every time you build something, right, you bundle something, it also spits out the source code. You like minify something and the source code is there. But in this context, we're extracting the result of this function without copying the implementation in the build output. So you're gonna see more example of this later. So we're gonna go back to the slides. So how to install Bun? So you can use npm globally. This flag G on Linux and Mac OS. You can use this curl and Windows PowerShell. And then after installing it, just to run Bun version, just to see if you already have the Bun, indeed. So features. Now let's dive into its powerful features. Bun is more than just a JavaScript runtime. It's a comprehensive development toolkit that includes package manager, bundler, test runner, and runtime. So you can quickly install and update packages because it's fast. And I will do benchmark later so you can see it. A bundler, right? So bundle your code and dependency into a single file. It's fast also. Test runner makes it easy to write and run tests of your code. And fast and efficient environment for your code to run it, compatible with existing Node.js and Dino code. So yeah, these features make Bun a comprehensive development toolkit. So let's move on to get a closer look at Bun's package manager. So this feature of Bun is designed to be faster and more efficient than these alternatives. For example, PNPM npm and yarn is still providing the same level of functionality and compatibility. But again, in the beginning, I told you to just take it with a grain of salt and try it yourself. So we're gonna try it here, right? And in order to do this benchmarking, you need a tool, right? A software. So I would highly recommend Hyperfine. So you can, you can install it in your Mac or your Linux or your Windows using WSL2. And then, it looks like this. So prepare. So you can see here, you can see it. So Hyperfine is the tooling. Prepare is preparing it, just warming it up. What's a prepare is here we have this removing the node modules. Warm up one means we're gonna run it once and then use the cache because it matters, right? When you have this cache, and then runs 3 times. So each command here will execute 3 times and get its average. So you can do 5 or 4, but 3 is enough. It's gonna take longer if you increase it. So this is just a simple command here to run just to see how you would do it on your own. So we can run this. Whoop. So I'm not gonna do it in front of you. I did it already before you came here because it's gonna take 5 minutes to 10 minutes. So it says here, this is the result of this Bun versus PNPM versus NPM versus yarn. First would be for the yarn, it says it was able to finish in 35 seconds, right? Bun 1.6, 1.5, 33, 1.5. Sorry, this is the range. This is it. PNPM install closer to Bun, as you can see. NPM, it took 5.5 seconds. And you have the summary here, and it says here, Bun install run 1.16 faster than PNPM install. Then what is this? This is just an error margin that could, happen here. You can also see here it's 3.5 faster than NPM, but there's no yarn because yarn it's too slow, and the benchmarking tool didn't include it anymore because it's way slower. So this is how you would do it yourself by running it, and then it will just say which one won this benchmarking on top of it. You can switch the npm the installing here, the command anywhere you want, but it's still gonna give you the same result that Bun install run faster than this. Get the point? All clear here? How to do benchmarking is just Hyperfine. Here it is, and then you have few flags to do: prepare, warm up, runs, and then the commands that you're comparing. Like could be like 5 or 10 commands. So you can see that Bun is winning here. Let's move to. Let's go back to the slides. So it's fast, but what are things that we can do with this package manager, right? I will just show you a few things from Bun's package manager. So just like how you use npm, yarn, and PNPM, you can do like install, add, remove, update, link, and PM. And in this package manager, we also have this global cache. So all packages downloaded from the registry are stored in a global cache. So workspaces also is included here, for example, in package.json to make it easy to develop apps in a monorepo setup. Also, Lifecycle scripts like pre-install, post-install, pre-uninstall, pre-publish only. So probably you've used SAS, right? Node SAS, and once in your project. So Node SAS, when you install Node SAS, there's a post-install that it will install the binary. That's why it takes so long to install Node.js. For example, if you have Angular and SAS, which is common, right, in Angular application, it takes so long to, if you have the deleted Node modules and npm installing it again, it takes forever, right? Because the Node SAS has this post-install, which again install this binary in your Node modules. So that's an example. You don't do it; the library do it for you. So Bun also has npm's overrides or yarns resolutions in package.json. So for specifying a version range for meta dependencies or the dependencies of your dependencies. A good example of this is like what we encountered last week. There's a problem with the which library was that again? It's Jest library, right? And somebody updated the dependency of Jest, which broke it. So to fix that, you can override the dependency of that. Again, the dependency of what you installed by using override. So that's how you would, use override. So without waiting for a fix for that open source project. So let's move to the test runner part of the Bun. So here's another benchmark which the Bun team, core team has done, and showing here Bun is faster than the rest Jest and Vitess. Again, let's do it on our side so we can see if that's true, right? Not just by looking at, okay, this benchmark, I'm gonna take it, I'm just going to accept it. No, just try it on yourself. So we're gonna do this, hyperfine again, warm up one because of the cache, let's use it, runs 3 times and get the average. What are the commands? vtest, right? Bun test, and then Jest. Who's using Jest here in their application? Okay, Jest, vtest. Oh, vtest also. Good, Bun test. Okay, it's just me. okay. So demo. Let's move to the demo again and see it for ourselves if this is true. So this is the command. I'm gonna use vtest run apple, test banana, and Jest orange. And I'm gonna show you why I'm naming them on like fruits. Here's the test. Just because when you're using vtest, you need to import vtest and then use it's described, right? Test and expect. And in Jest, you don't have to write anything because your editor can know it. And in Bun, right, I have to use Bun. And I don't want to like write, delete. I'm just going to, since they're all of them are using the same test right here, so I'm just going to tell which one to run. Again, they're both having the same describe here. So let's just go back and use it. It is gonna be faster than installing, so I'm just going to show it here instead. Running. So the winner is Bun. Again, here, I'm not lying, right? See it yourself. Here, it says Bun test banana run 23 times faster than vtest, right? And then again, margin of error here is I don't care. What I care is about this one, right? And it's faster, 37.43 faster than Jest. So isn't that incredible, right? So now we know that they're not lying, right? So we can go back to what we're doing here and then read more about what Bun can do. So you can also do a lot of things with Bun as a test runner. Yet it is fast, built-in JS compatible test runner, and tests are executed with Bun runtime and supports these features. So in Bun's test runner, use what you have learned from Jest because it's using the same API, right? Tests are written in JavaScript and TypeScript with a Jest-like API. You use describe, test, async, etc. Watch flag for running tests. You're just going to reload it and change something. Lifecycle hooks, like you can do setup and tear down anything you want with before all, before each, after each, and after all. Create mocks with mock function, right? Like this. What else? Snapshots. You can capture the state of a web page at a specific moment during testing and well through snapshots. It lets you also change what time it is in your tests by using set system time. What about DOM testing? Who does DOM testing here? Or component testing? Yeah, most of us, right? So fully compatible with existing component and DOM testing libraries such as RTL or React Testing Library and HappyDOM, right? What about code coverage? So it has built-in code coverage reporting, which makes it easy to see how code coverage your tests have. Let's see. So moving forward to the building part, right? A bundler is a tool used in web development to package together various assets such as JavaScript files, CSS files, images, and other resources into single optimized bundle for deployment to your web server. So, but bundlers also help in reducing HTTP requests. Why? Because apps nowadays don't let browsers send HTTP requests per file, right? Bundling combines multiple files into a single package, reducing the number of requests and then improving load times. So you also have these code transformations and, more importantly, framework features. So bundlers enable framework-specific features like file system routing, right? That any one of you have used Noxt, Next.js, Remix, SvelteKit, right? And in Angular, we have this analog.js. All of them using file system routing, which what bundler does for those frameworks. And also code collocation. It's bundlers are responsible for that. When I say code collocation, have anyone here written Remix or Next.js, right? When you write a server or a loader in Remix, the bundler knows that this function will only run in the server, right? But you can also write components, for example, in Next.js. So bundlers are responsible for detecting which code only runs in the server and then which code in the file. So these are, in just one single file, but the bundler knows which one to run in the browser and which one to run in the server. So that's called collocation, right? And what else do we have here? It's like my mouse is not working. So yeah, in short, bundlers are, is essential for efficient loading. Code compatibility, framework functionality in modern JavaScript applications. And in Bun, again here, it's fast. It's faster than ESBuild, which Vit is using, faster than RSPack, faster than Parcel, Rollup, Webpack, but no demo here, sorry guys, because I don't have any huge repository that doesn't require any plugins for every bundler, because each of them had its own setup of plugin system. So I need to, like, one by one like use plugin. Some of them doesn't have the plugin yet for a specific feature. So, but I will show you how to use this bundle later. I'm going to run something. So, okay, let's take a look what different supports we can get out of the box from Bun. So, bundling using CLI or using JavaScript. So this is the CLI. JavaScript looks like this. And then loaders. For loaders, these are the default loaders for both for building and also runtime. JS, CJS, MJS. Plugins. So you can write your own plugin. For example, something that does CSS extraction, macros and client-server code collocation. And it looks like this. You can start with this. This is the pattern. This is the API, and this is the type, bun, plugin. So macros. So in programming, both Zig's comp time and Bun.js macro system are designed to perform computation at compile time rather than at runtime. However, they operate in different contexts and are used with very different programming environments. So here's an example function that returns. I'm going to do this later. So this is just a random number, right? So note here that macros are indicated using import attribute here. I'm going to use my laser here. Let's see if this is going to work. This attribute here. So if you haven't seen this syntax before, who've seen this syntax before here or used this in production? So if you haven't seen this syntax before, it's a stage 3 TC39 proposal that lets you attach additional metadata to import statements here. But you need to turn on your compiler as ESNext or using the latest ES to enable this. Otherwise, you're going to get squiggly, which is I'm going to show you later. And then, this one I'm going to do later. You won't see the code of the random function, the source code, here because it was, again, executed during the bundling. So we're going to do that. Here. It's a macro. Where's the macro here? So I have this function. I'm exporting it, right? Random, mat random. This is just it. Importing it in my main.tsx. As you can see here, when you hover your mouse, input attributes are only supported when the module option is set to ESNext or NodeNext or preserved. So we're going to do that. To enable that, we will go to tsconfig. Save. Now our module set to ESNext. Go to main.tx. It's gone, right? Then when we're going to run this main.tsx bun build, we're going to build it and set the directory name out. That's okay. Build or this would work. There you go. We have this bundled, right? Main.js. Look at this. Console.log. But where's the random TS? It's not included in the bundle, right? The output, because it's a macro, just like the comp time in Zig, which you can do a lot of things, at build time, so you don't have to run it at runtime. That's why it's faster, right? So it's not included in the output build because of, again, this type. So, yeah, we can now move back here. Okay. What about versus ES build? So just comparing ES build and Bun, no bundle flag, because it's always bundled by default in Bun. You don't have to use this dash bundle. So no built-in development server or file watcher. It's intended to run with bun.serve and other runtime APIs. And Bun doesn't support ESBuild's entire plugin API surface, but the core functionality is implemented. So if you're not familiar with ESBuild, ESBuild is what Vite is using in their development mode, right? And everyone here is like, anyone here is still using React scripts or the CRA, the old CRA in their project, or everything is who's using Vite here in their project? Vite. And then the rest like Next.js, Webpack, right? Okay, good. And if you want to see the complete APIs between ESBuild and Bun, you can just go here in this docs. So now the last part, the runtime part. So Bun uses the JavaScript core engine developed by Apple for Safari, which outperforms V8 engine, used by Node.js and Chromium-based browsers in most cases. Additionally, its transpiler and runtime are built with Zig runtime, which is 4 times faster startup times on Linux compared to Node.js. So a few of what you can do in Bun's runtime, Bun has the capability to execute TypeScript, TSX files directly, similar to regular JavaScripts without needing any additional setup. Bun automatically processes your env files. No need for any library like .env, right? What else? Bun implements these web standards and are partially or completely supported. This below here is HTTP, URLs, web workers, streams, blog, WebSockets, etc. And Bun also strives to fully support the Node.js API, ensuring that most NPM packages designed for Node.js to work seamlessly with it. Plugins also, you've seen already the plugins earlier. It's the same plugin here because the plugin works in build time and runtime. Module resolution, on how you import your modules. By default, it supports CommonJS and ES modules by default. So these are how you would import your modules. Common modules. You've noticed if you've seen require something, that's meaning that it's using CommonJS, and then the import is ES modules. The difference between CommonJS and the ES modules by default is being supported by browsers. So you can write something in your browser, in your console, or in script, JavaScript, with import, and it's going to be read by your browsers. What else? Another difference, just to give you an additional information, difference between CommonJS and ES modules. ES, they're pretty much the same, synchronous, but in ES modules, you can do it asynchronously using the import function. Anyone here have done code splitting or lazy loading in their SPA, like import? Even in Angular, you have this import, right? Which is just to create this lazy loading routing system. So that's the difference between CommonJS also and ES modules. That you can do that. You can invoke it in an asynchronous way, and it will wait. And then as you go on, it's like per request thing. What else? Bunfig.toml. So this is how you configure the default configuration of Bun. Just setting it. If you're not familiar with bunfig.toml, it's just like YAML, and then it's just for readability. No curly braces whatsoever. It's clean. What else? For the API side, there's few. You have workers, right, which lets you start and communicate with a new JavaScript instance running on a separate thread while sharing I/O resources with the main thread. Streams like the response you see in ChatGPT apps, right? Just like it's slowly revealing the text. File I/O for file system task. Bun also implements high performant SQLite tree driver, file system router for solving routes against file system paths, Node API. It's an interface for building native add-ons. So it implements 95% of interfaces in Node.js. Those common, but there's still a lot to complete. Okay, for the runtime, what I can do is, I think, what I can show you is a framework that uses Bun as their runtime. So this is Hono. This is a framework where you can build a full stack or an API or an RPC call, whatever. You can do a lot of things here. It's supporting Dino, Node.js, and Bun. Well, I'm just going to show you the Bun part for the runtime, just like this, right? So yeah, this is just an example of a framework that uses Bun as a runtime, and then spin up their a local server. Yeah, so Hono, if you haven't used it, you haven't seen it, it's a pretty much a decent a framework, JavaScript framework for building APIs or front end or full stack. So here it is. And what else I can say here would be, this is just an example. You can, since Bun is pretty much new, right? You can build your own framework and use Bun as a runtime, as a bundler with its own test runner. It uses its own Bun's test runner. Yeah. So normally we see it here. You just don't touch it directly. So no running codes here or scripts. We can just move to slides. And we're almost there. So key takeaways. So Bun is fast, Zig is fast and readable. Bun is faster than PNPM, NPM, and Yarn. The Yarn version is 1.22.11. This is the classic Yarn, by the way. I used the classic Yarn earlier, not the version 3 and the version 4. Bun as a test runner, it's a good choice also. Bun's a bundler, okay in development and small apps in prod. Because again, they're still missing some of the Node.js APIs. And if you're using it, it's going to be a problem. It's not supporting. Bun as a runtime, so okay in development and small apps, just small applications in prod. Resources, so you can go here, bun.sh for their documentation, ziglang.org if you want to know more about Zig, same as like fast as Rust, but more readable. That's what the author described, how the experience his experience in Zig. Hono.dev, and this repo that I'm doing, the app that I'm using here with commands in the terminal, those are all saved in its per folder, the README. So you can see here. Oops. So we can just go here just to show you, right? And I have here how to run it, the test also how to run it. So yeah, it's all in the repo. It's there. And yes, thank you for paying attention. Yes. Thank you for paying attention. And if you have any more questions, I'll be just here, anywhere there. You can just approach me. And yes, thank you again.